Good afternoon everyone. In the last video we have understood how BJT works as a switch in the cutoff region and saturation region, and I have also shown the theoretical calculations to you people for IB, IC and BC. Now let's have a look at the connections which are to be done with the help of this particular kit. So we have the input port here, we have the output port here. This is the VCC with respect to ground, of course. Between these two you will be connecting the ammeter. Between these two you will be connecting another ammeter. This will measure IC, of course, and this will measure IB, right? So let's make the connections. I have the power supply. I'm using the first channel of the power supply to apply VCC to the circuit. So positive of the supply goes to VCC of the circuit. The negative of the supply goes to ground. I can either connect it here or here. Let me connect it here. Yeah. Now let's apply input. Applying input will, as I said, we are going to apply fixed DC 5 volt to the input. If I want to have the BJT in the saturation mode, if I want to have the BJT in the cutoff mode, I will be applying 0 volt. I have set this supply to 5 volt, meaning I am going to keep the BJT in saturation mode. So this second channel of the DC power supply will be used to apply input to the circuit. So the positive of the supply goes to the positive of the kit. The negative of the supply goes to ground, like this. Then let's make the connections for the ammeter here. So this is the ammeter. If you can see, this ammeter has been configured, this multimeter has been configured in the ammeter mode, common यहाँ पे, and positive has gone to the milliampere. So the positive of the milliammeter will be connected here and the negative of the milliammeter will be connected here. I hope you people remember that the ammeter needs to be connected in series with the circuit. Similarly, I have another multimeter which is in the ammeter mode, common here, milliampere here. So the positive will go here and the negative will go to the negative of the circuit, like this. And this is going to measure IC, this is going to measure IB. And then I have one more multimeter. This multimeter has been set in the voltmeter mode, common here. The positive has been connected to the voltage side. So let this go to the output part, positive, the negative goes to the ground. So this is of course between the collector and the emitter. So this is going to measure VCE. So let's remember that this is IB, will be measured by this multimeter. This is IC, will be measured by this multimeter, and this is VCE, measured by this multimeter. Yeah. So before I show you the readings, first of all let's understand, because I gave the input as equals to 5 volt, hence the BJT went into saturation. So it is acting as a closed switch, hence the LED is glowing, right? If you want to see what happens when I put it into cutoff mode, I need to give the input as 0 volt. Have a look. So I just reduce the input voltage to 0 and the LED goes off. If I have made the input to 0, I get back the voltage of the input to 5 volt so that my BJT enters into saturation, right? That's the input. Now let's have a look at the readings for IB, IC and VCE. So IB is 0.95 milliampere, IC is around 6.55 milliampere, and VCE is around 32.1 millivolt. Yeah. So let's write down these readings. This is the saturation. So in my notebook I have already written the theoretical values for IB, IC, VCE. Let me write down the practical values. For IB, as seen on the multimeter, it is 0.95 milliampere, 0.95 milliampere, right? Then IC is equals to 6.58 milliampere. So let me write down this as 6.58 milliampere. And as seen on the multimeter, VCE is equals to 32.1 millivolt. So VCE is equals to 32.1 millivolt. Yeah, so these are the readings for IB, IC and VCE practically. Now let's go into the other case where I have the cutoff region, right? To have a look at the cutoff region, I'm just going to reduce the input voltage to 0. The moment it gets reduces to 0, this LED has gone off. Okay, and let's have a look at the corresponding readings for IB, IC and VCE. IB is equals to 0, IC is 0 and VCE is equals to 3.6 volt. Yeah, so let me write that down over here. IB is 0, IC is 0 and this is equals to 3.6 volt. Okay, so just compare the theoretical and the practical values. Theoretically IB, IC are 0 and practically also they are 0 in the cutoff region. VCE is equals to 3.2 volt theoretically and practically it is equals to 3.6 volt. So the readings are matching. Similarly for the saturation region, IB is 0.91 milliampere theoretically, practically it's 0.95 milliampere. IC theoretically is 6.38 and practically it is 6.58 milliampere, and VCE is 0.2 volt. Here it is 32.1 millivolt, meaning approximately 0.03 volt. Yeah. So if you can compare these readings, the theoretical and practical readings match, and we have seen that these theoretical readings are obtained because transistor is working as a switch in saturation as well as in cutoff region. Hence that thus verified BJT works as a switch. Thank you.